Hello, and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 8, lesson 5, practice problems. So, our first problem here says, explain how you know that the square root of 37 is a little more than 6. So how do we know the square root of 37 is a little more than 6? Because the square root of 36 equals 6, and 37 is a little more than 36. So the square root of 37 needs to be a little more than 6. Explain how you know the square root of 95 is a little less than 10. Well, the square root of 100 is equal to 10. The square root of 81 is equal to 9. The square root of 95 is really close to the square root of 100, so it has to be a little less than 10. Explain how you know the square root of 30 is between 5 and 6. The square root of 25 is equal to 5. The square root of 36 is equal to 6. So the square root of 30 needs to be between 5 and 6. For the next one, plot each number on the number line. The first number is 6. That's 6. That one's pretty easy. If we look at this last one is 7.5. That's halfway between 7 and 8. Now, the next ones are a little trickier. The square root of 83. Well, the square root of 81 is 9, so the square root of 83 needs to be just a little more than 9. Now we have the square root of 40. Well, the square root of 36 is 6. The square root of 49 is 7. So it needs to be between 6 and 7. "40" is a little closer to 36 than it is to 49, so it's probably a little closer to 6 than 7. So I'm going to put the square root of 40 right about there. Now, next one, square root of 64. 8 times 8 fell on the floor, picked it up, it was 64. The square root of 64 is 8. Okay, we have some numbers on our number line. The equation x squared equals 25 has two solutions. This is because both 5 times 5 equals 25, and also negative 5 times negative 5 equals 25. So 5 is a solution, and also negative 5 is a solution. This says select all of the equations that have a solution of negative 4. 10 plus negative 4 is equal to 6. All we have to do for this is substitute. 10 subtract negative 4. Subtracting a negative is adding. 10 plus 4 is not equal to 6. That's equal to 14. Negative 3x equals negative 12. So if we substitute in negative 4, negative 3 times negative 4, negative times a negative is a positive, that would give us positive 12. D, negative 3x equals 12. Negative 3 times negative 4 equals positive 12. That works. 8 equals x squared. If we substitute in negative 4, we would have negative 4 squared equals 8. Negative 4 times negative 4 is 16. That's not equal to 8. That does not work. X squared equals 16. If we substitute in negative 4 here, negative 4 squared, negative 4 times negative 4 is positive 16. So A, D, and F work for this one. Okay, our next question says, find all the solutions to each question. So what are all of the solutions to x squared equals 81? Well, what number can we multiply by itself and get 81? X equals 9, because 9 squared equals 81, but also x equals negative 9, because negative 9 squared, or negative 9 times negative 9, is equal to positive 81. X squared equals 100. X equals 10, because 10 squared is 100. Or x equals negative 10, because negative 10 times negative 10 equals positive 100. The square root of x equals 12. So x is equal to what? Well, because this one is doing the opposite of what these are, we have to think about the square root of some number is equal to positive 12. What number do we take the square root of and get 12? Well, that would be 12 squared, which is 144. The next problem is select all the irrational numbers in the list. Irrational, we remember, means a number which cannot be written as a ratio, a number that cannot be written as a fraction. 2/3, that's a fraction, that can be written as a fraction. Negative 123 over 45, that can be written as a fraction, it already is. The square root of 14. Can we write the square root of 14 as a rational number? Well, the square root of 9 is 3, and the square root of 16 is 4, so that is not going to give us a whole number, which means that has to be an irrational number. The square root of 64. Well, the square root of 64 is 8. Can we write that as a fraction? 8 over 1. That can be written as a fraction. The square root of 9 over 1. 9 over 1 is 9. The square root of 9 is 3. Can we write that as a fraction? Yes, we can. 3 over 1. The next one, the negative square root of 99. Well, the square root of 100 is 10, so the square root of 99 is not going to be a whole number. Whether it has a negative sign in front of it or not, it is not something we are going to be able to write as a fraction, so that is an irrational number. The negative square root of 100. The square root of 100 is 10. So this one would be negative 10, or negative 10 over 1 if you want to write it as a fraction. So there were 2 irrational numbers on this list. Okay, our next problem here. Each grid square represents 1 square unit. What is the exact side length of the shaded square? So if we want to find the exact side length, first we can find the area by enclosing it. Our outer square here is 5 by 5, so that has an area of 25 square units. Our little triangles here are 2 units by 3 units. 2 times 3 is 6, over 2 is 3. 3, 6, 9, 12. Those outer squares are 12 units, which means the area of our inner square is 13. If the area of a square is 13, how do we find its side length? Well, if you know the area of a square, to find the side length, you take the square root. So the side length is the square root of 13. Square root of 9 is 3, square root of 16 is 4, so this will not be a rational number, it will be an irrational number. The side length is the square root of 13 units. Okay, for each pair of numbers, which of the 2 numbers is larger? Estimate how many times larger. Okay, so we have 0.37 times 10 to the 6 and 700 times 10 to the 4. Neither of those are in proper scientific notation now, so let's quickly put them in proper scientific notation. 0.37, 1 digit in front of the decimal point, would be 3.7 times 10 to the... That was a number less than 1, so we want to make this smaller. We moved it 1 spot. 1 smaller than 6 is 5. Now this one we want to be 7.0 times 10 to the power of... Well, our decimal point here, we moved it 2 spots. If we move that 2 spots, this was 4, it will become 6. So 3.7 times 10 to the 5 and 7 times 10 to the 6. Which one is larger? This one. How many times larger is it? Well, 3.5 is half of 7, so it's about 2 times larger just looking at the numbers, but there is 1 extra 0. There's 1 extra place value here. So instead of being about twice as big, it is about 20 times larger. Now our next one here, this one is already in scientific notation. This one is not. So that would be 1.5 times 10 to the power of 6. So now we are looking for which one's larger, 4.87 times 10 to the 4 or 1.5 times 10 to the 6. This one has to be larger. Now, how many times larger? Well, this is close to 4.5. From 1.5 to 4.5 is 3 times larger. Oh, we're actually going the other way. How many times larger is this than this? So if we think of 1.5 over 4.5, that's 1/3. But then there are we're moving this 2 decimal spots. So that's going to be about 30 times larger. Because 1/3 move the decimal point 2 spots. Now, 500,000 and 2.3 times 10 to the 8, which is larger. Well, let's start out by putting this one in scientific notation. That would be 5 times 10 to the power of 1, 2, 3, 4, 5. So we have 5 times 10 to the 5 and 2.3 times 10 to the 8. So which one's going to be larger? This one's going to be larger. How many times larger? Well, to go from 5 to 2.3, that's about 2.5. So 5 into 2.5, except we have 3 extra decimal places. So 5 into 250. So that's going to be about 500 times larger. Okay, last problem. The scatter plot shows the heights in inches and 3-point percentages for different basketball players last season. Circle any data points that appear to be outliers. Are any of these points outlying the standard data? This is an outlier. That point is significantly different than the rest of the data. Compare any outliers to the values predicted by the model. Well, this point here is about 3-point percentage. Here it's at 30, here it's at 15. So this is about 15 units away from our model. The rest of these, if we look at them, this one is probably the next furthest away. And this one goes from 30 to here, which if that's 30 and that's 45, the middle of that is going to be 37.5. So this is 7.5 or 8 units away. This point is twice as far away. Okay, this has been another episode of Mr. Boskin Does Some Math. Thank you for tuning in. See you next time.